So yes, in last video we discussed about the VBT. Now we are again I'm going to give a little overview just because we discussed a little in last video. Then we have single bond. Wait, let me just write first. Single bond, then we have the double, then the triple. What these are exactly known as, these are the bonds. Okay, I discussed the overlapping of SS, SP and PP orbital in the last video. I would suggest you to watch that first, but still this is the overview. So when single bond, this would be the sigma bond only. Sigma bond is the strongest. Well, this would be sigma bond. When it's double, one should be sigma, second should be pi. Okay, how it will be represented if these both, this is a single bond, this means this is the single. Okay, but if these are the double, the upper one would be sigma, second will be pi. Okay, then still we have the last would be pi, first would be pi, then pi. If we have 3, so this would known as pi. Then the second would known as sigma, then third would be pi. Okay, these would be the sharing in these all. Okay, so now we are discussing what are the condition for overlapping in VBT. Okay, so what are the condition? The orientation should be same. Orientation should be same. This means their shape, the size should be same. Their energy would also be. Okay, then we have orientation, energy, and the atomic orbitals of non-metals should be unpaired. The atomic orbitals should be unpaired. Should be unpaired. Then they have the charges like P, X, Y, and Px cannot overlap. What this exactly? This is showing if there is P, X, Y, this cannot overlap with Px. Px. Why? Just because if this is the like the shell orbital, this is also orbital, this will form the pi bond. Or there's another story, like we have Px, orbitals are like Px, we have Py, and the third we have Pz. Okay, so we have these three, so they both cannot overlap each other. Okay, this point is only this. Then there would be first covalent bond. Okay, so they will have covalent bond first. Covalent bond, there should be unpaired. Unpaired bond would be highly reactive. Highly reactive. Oh God, sorry for this. Highly reactive. Then we have lone pair, which would be normal, like the normal pi bond that is all. The bonding should be no less reactive in this one. Like we have dot, solid, these all. There should be coordinate, covalent, lone pair as well. Okay. Then we have another kind of the last sharing orbital. That's a p subshell overlapping. If this is the double one, this will be X and this will be Y. This seems like flower. Again here we also have the same. So in these they will have sigma bond. Okay, and this will fuse with this one, overlap, this will have pi.